what is Lattice bringing new to AI? Because everybody is talking about AI. So I'm assuming Lattice also is doing something there.
Yes.
So
we're actually doing quite a bit there.
So can you tell me what you're up to over there?
Okay, so I'm going to take the AI and I'm going to break it into two areas first. One is AI in the data center. So you hear about all these AI racks, you hear about NVIDIA, AMD, and other companies building these AI accelerators in the data center. Well, Lattice plays in those because we are actually enabling a lot of those AI systems in the data center with our FPGAs. We're doing control functions on the board. We're doing security. So we're a good companionship to a lot of these processing units, GPUs as an example, that are in the data center. So you take an AI server, you're going to find us there. If you take switches and routers in data center infrastructure, you're going to find Lattice there. So as AI gets deployed into a data center, we benefit from that. Now that's in the data center. Now there's also AI happening on the edge.
Yes.
And on the edge, usually what happens is you want to put intelligence there, but you don't have, your application doesn't necessarily have the ability to wait for it to go to the data center and come back. The latency has to be very, very short.
Okay.
So a good example of that is in automotive applications. If you have ADAS applications and you're putting artificial intelligence, that another vehicle coming, stop sign, you have to have that intelligence on the edge.
Yes.
We are also a companionship for those where we do the sensor fusion.
Okay.
So take a vehicle, and actually Mazda did a press release about a year ago, maybe a little over a year ago, about how Lattice is enabling their ADAS systems in their crossover models.
Okay.
So what we do is the vehicles have cameras.
Okay.
And the cameras are looking at everything. We take the camera data, we then aggregate all the sensor data into our FPGA, we co-process it, and then we send it to the compute that does the decision making, or the AI. So we're in the AI data path. That's one example.
Okay.
So we benefit from AI at the edge that requires high performance. But we also benefit from AI on the far edge, where you do applications and you're running the AI on the Lattice device.
Okay.
So a good example of that is if you go into a factory and you have operators working on equipment in the factory, and they're hitting the display and turn on this, shut off that. Well, we can sit on those displays and we do the artificial intelligence. So is the operator authorized to hit that? Is he wearing a hard hat? Is he wearing glasses? Is he looking at what he's selecting, or is he turning his head and hitting any button? We do this type of artificial intelligence. If the operator is not there, well, let's shut the display and save power in the factory. So we do that. We can also do, and we're in production now in factories where we're sorting out bad peppers, good peppers, defects in rice, and so those are run on the Lattice FPGA itself. So if you look at AI, there's a lot of things happening in AI. So if it's in the data center, we benefit. If it's high performance on the edge, where we do sensor fusion, we benefit. And if it's in the far edge, where we're doing some of the AI applications on the FPGA, and we do that at lower performance, of course, but also in milliwatts, then we benefit from that as well.
Interesting. You mentioned benefits, but how does an FPGA compare with AI running on a CPU or GPUs?
Yes.
What's the benefit over there?
So there's a few differences. If you need very high performance and you're willing to live with high power, then you can use a GPU or a CPU, and we'll be a good companionship for it. And the companionship is about this whole sensor aggregation and fusion. However, if your application requires to run at very low power, and you don't need necessarily more than one top of performance, then an FPGA is a more cost-effective, lower power solution for that type of an AI application. So think about a vehicle running at 100 kilometers an hour and decisions have to be very fast versus you're in a factory with an operator, or you're sorting, or you're doing object detection on things moving on a conveyor belt. You don't need as high a performance. So then an FPGA becomes a more cost-effective, lower power solution.
What about an ASIC? How does an FPGA compare with an ASIC?
So FPGAs have flexibility.
Okay.
So if you decide that you want to change your model, if you decide that your AI, you have some secret sauce that you don't want to be the same ASIC as everyone else, you want to differentiate on your application, then an FPGA is more ideal. I'll give you an example. We worked with a company and we were competing with an ASIC. And so the ASIC had this AI accelerator engine, and we had our FPGA where we programmed the AI model and accelerator into the FPGA. And then as we're working with the customer and competing with the ASIC, we came up with a really new use model for the customer. We said, oh, how about we try this use model? So we just reprogrammed the FPGA and we demonstrated a different use model. The ASIC vendor said, oh, I have to respin my ASIC. So and I think the customer said, well, you're more future-proof because you can reprogram the FPGA, put a different model, do a different use case, where a hard ASIC had to respin the silicon in this scenario, and that would take more time, more money. So if you take our FPGA and put it into your system, and in the future you decide you want to update the model, update a use case, it's reprogrammable, it's reconfigurable, so it's more future-proof.
Interesting. So there are also some trade-offs to consider between power, when you're using AI at the edge specifically, between power and latency, compute capability. So how do FPGAs benefit, or what kind of functionality do FPGAs provide in that case?
Yeah, so when it comes to latency, FPGAs are known to be very good on latency, very low latency, and that's why we are a good companion chip when we do the sensor aggregation, and then we take the data and we send it to the GPU, because our latency is really very low. It's very, very low. And that actually is one of the good benefits of an FPGA, is the low latency. And the reason why is, if you compare an FPGA to, let's say, an MCU compute or something like an MCU, MCUs are called deterministic. You give an instruction, it does something. Instruction, it does something. So it's kind of serial. An FPGA, you program it, it's parallel. So you can do multiple instructions at the same time. So you get higher performance and much lower latency because of the parallel performance and the parallel processing within the FPGA.
So that means, so what you're trying to say is an FPGA is more programmable versus versus an ASIC, which has a fixed function, which comes with a fixed functionality.
Yes, and with things like an MCU that's very deterministic.
Yes.
It does operations serial.
Yes.
An FPGA can do multiple operations in parallel at the same time, so you get higher performance, lower latency.
Interesting. Could you also explain how FPGAs deliver low latency inferencing for especially time-sensitive applications?
Yeah, so this goes back to the parallel processing of the FPGA. So we can take in multiple data at the same time, process it at the same time, so we get much higher performance and much lower latency within an FPGA. But again, it's between that range of a few tops, but also very low power in the milliwatts of power.
Are there any? Can you share any examples of any customer benchmarks or any industry benchmarks that are applicable or familiar to you?
Yeah, so benchmarks are, there's no standard way on how people do benchmarks. It's really around the use model. Do you achieve the use model function? And so the examples like we talked about.
Yes, the
industrial use case of the display, or also in a laptop. If you go into laptops today, and this was public, we're used within Dell laptops, and we're used in Lenovo laptops, and we sit by the camera and we do the AI function in the laptop, and we do different use models. So what are the use models on the laptop? Well, one of them is if you approach the laptop, it turns on because it recognizes you. Like your phone. Your phone has a gyro. So when you pick up your phone, it says, oh, somebody's picking me up, and so the camera turns on, and then your phone turns on. But in a laptop, you don't want to shake it. It's at the desk. It's idle. So it has to be always on. So if you approach it, our FPGA running in milliwatts will see you, it turns on the display. But then we add more use models. So what are the type of use models? Well, if somebody is standing behind you, it's okay. But if they're standing behind you looking at your display, you're in a coffee shop, you're in an airport, we can warn the user that somebody is shoulder surfing and looking at your computer. We do use models around wellness. Is your posture good? Collaboration. Are you centered in the screen? So it's really about, do you achieve the use model requirements? That's really what matters to the customers. We can say tops as an example, and we say, oh, we're, single tops and lower. We're not much faster than that, but that's good enough for a lot of the use models that we're trying to achieve.
Okay. In the beginning, when I had asked you about what is new for FPGAs, you also mentioned security as an aspect.
Yes.
So circling back to that, what makes security at silicon level such an important focus?
Yeah, so security is something that's really important in our industry, and you hear about it all the time. Somebody hacks into a system. Recently, people were saying, in Heathrow Airport, there's a cyber attack. And things like that. So you really have to protect, and it's not just software protection, it's hardware protection as well. The way software protection works is when the CPU, as an example, boots up, then the CPU is trying to monitor and ensure that the system is secure, that nobody can come in. But the adversaries get really smart. They say, okay, I'm going to take control of the CPU before it boots up. So then it boots up in an unsafe state. Well, then you have to protect the hardware.
Yes.
You have to make sure that you securely boot up the system where nobody takes control of it while it's booting up.
Okay.
So our FPGAs are very unique that, number one, we have very fast boot time. So in a system, we're typically the first device to turn on.
Okay.
So when we're the first device to turn on, that puts us in a good position to be the security. And then what we do is we actually look at all the boot codes and the firmware, and we monitor them.
Okay.
And we keep, and because we're a root of trust, we know what the firmware should be. So we can protect it, we can detect if something changed in it, and we can recover if needed.
Okay.
So if somebody comes to change the boot code to take control of the CPU, we'll detect it. And we'll say, hey, that's not a good boot code. And then if needed, we'll revert back to the golden one to make sure that it boots up correctly. So we do that. And then we have a lot of encryption in our device to ensure that between us and the other components in the system, that we have the right key exchanges and it is secure. And then more importantly, I would say, as we look into the future, people in the security world are concerned about quantum computing coming.
Yes.
And in quantum computing, when you have these computers that are very powerful, a lot of the encryptions we have today can be broken. So we have to put new standards of security, which we call post-quantum crypto ready, PQC ready. And so our FPGAs have a lot of those capabilities today. We're leading in that area. So we're helping our customers now deploy systems so that these systems, when they're deployed in the field, are ready when post-quantum computing comes out and people try to hack it. And really what the bad actors are doing, which is kind of scary, is they're stealing data now, and they're waiting for the time when they have quantum computers to go break that data and read all the stuff.
Okay.
And so there's a big push in the industry now around data centers, around telecommunication, critical infrastructure. How can we protect the systems in advance because we know quantum computing is coming? And so our FPGAs have a lot of these security engines to go do that. In addition, it goes back to what we talked about, FPGAs are programmable. So we have something that we call crypto agility. And crypto agility is, let's say you have, NIST has a standard now for cryptography to protect against post-quantum computers. And so the industry is using that, and we have that in our FPGA. But the standards are challenging people. How do you break that? They want to see, can anybody break that? Well, let's say somebody broke it. Well, crypto agility means our FPGA we can program the new cryptography that's needed because we're reprogrammable. So if we wanted to change it, we can. That's called crypto agility.
Okay.
And so that's something that is a benefit of the FPGA in doing security. This goes back to the future proofing we're talking about.
Yes, yes. So how is Lattice, you hinted a bit on what Lattice is doing. Could you elaborate on how Lattice is prepping up for setting up these security standards when it comes to post-quantum?
Yeah, so we work very close with the industry, the standard bodies, our customers, the ecosystem, researchers and academia as well. And so as the industry determines what are the right IP cores, what are the right cryptography to use, we leverage that data and then we integrate that into our FPGA so that customers can leverage that as well.
Across the globe, you're doing this across the globe, and what kind of traction are you seeing from India regarding the quantum aspect of our discussion?
Yeah, so we had a developers conference, and in our developers conference, we had some of the top customers talk about Lattice and security. We had Meta presented a keynote. We had Microsoft come in. We had Ericsson come in as well. And so we're working with a lot of companies and deploying these new standards into systems. And that learning gets taken and it's applied to other customers as well. Even customers within India are leveraging that as well. So as India deploys new servers, new communication networks, a lot of these new security capabilities get deployed within India as well.
We discussed a lot of emerging trends. What are the design challenges or new design requirements that emerge with all of these new emerging technologies?
Yeah, safety critical, security we talked about, computer vision, AI. There's one application that I say embodies a lot of these together, which is gaining momentum, and that's around humanoids. You read a lot about humanoids and people building humanoids. Well, think about what a humanoid is. You have to have artificial intelligence, so there's the edge AI, and it has to be high performance. You have computer vision, it's looking at the surroundings. There's a lot of motor control and motion, which means low latency, because if you don't have low latency, your robot doesn't look like it's human. It's it doesn't flow. The fingers, if you're going to play the piano, you need to have low latency. You need to have fast reaction times, real-time communication between an instruction and what you want to do. You have to have real-time. FPGAs are ideal for all of that. So we're good for sensor aggregation, co-processing, send that to the AI compute. We're also can do some of the simple AIs. So if you have a barcode reader or it wants to recognize someone, we can do that. But also the low latency, multimodal access, FPGAs are very good for that as well. So, and safety and security matter in humanoids as well. You have to make sure that it's secure, that it's safe. And so a lot of these emerging trends, and we're working with many of these companies today around humanoids, is something that benefits from many of these emerging trends that you talk about.
Out of all of these trends, which will be the quickest to adopt FPGAs?
I think today FPGAs are being adopted in many of these applications that I discussed. So when you think about robotics in a factory, FPGAs have always been in robotics, but now it's migrating more into humanoids as well. When you think about security, people were looking at FPGAs for security. Now post-quantum is the next generation of security. It will go in there. Computer vision, displays, there's lots of computer vision now in equipment, and FPGAs have been at the forefront of that and continue to be there as well. So I think FPGAs, if you think about it, it's an industry where an adoption where it goes back to what we talked about in the very beginning. Anytime there's new inflection points, new technologies, new deployments, that's really good for FPGAs. So that's driving more adoption of FPGAs.
In India, India specifically, which sectors do you see, or which emerging technologies do you see adopting FPGAs, especially lattice FPGAs quicker?
Yeah, so because FPGAs are across multiple end markets and segments, and India's got a lot of really bright talent, I must say. I mean, there's a lot of very bright talent here. And a lot of multinational companies that we work with overseas have lots of design and innovation centers in India. So when I gave the examples in communications, there's a lot of communication companies that have offices here. And so we work with the Indian companies here on how do we innovate in communication networking. There's a big push for made in India for compute, whether it be client devices, servers, how do we start building? So we engage with them as well on the compute side. Industrial, factories, there's a lot of multinational companies that have development sites here, but there's a lot of Indian companies building around robotics and drones, and we engage with them as well. Aerospace and defense in India, that's something that India has been, well known around the globe, that India is really driving not just space, but their own defense applications as well. We engage with customers in that area. Automotive is an area that India has been trying to innovate in as well, and we work with customers around automotive as well. So India is very bright people, lots of different applications representing not just India, made for India companies, but also multinational companies that are present in India. And FPGAs are good for lots of these applications.
At this conference, you've launched this chip called Avant.
Yes.
So is that targeted towards Indian consumers?
Yeah, so it's actually targeted towards our global customers worldwide, but clearly there's lots of applications within India for our Avant product. And Avant is our mid-range FPGA.
Okay.
And it has very low power, small form factor, very high performance and throughput, and it's used in a multitude of applications from AI to robotics, industrial automation, automotive applications.
So it's been a year since, the Pune office has been functional, operational. So could you give us a sneak peek into what kind of innovation is happening there? What kind of R&D are you doing going and building? Any sort of IPs that are going to come out of there?
Yeah, so we had our official ceremony to open it in the beginning of the year in January, and now we're well over 100 employees, approaching, we're going to get to 200 at this rate very quick. But there's a lot of innovation happening there, and the talent base in Pune is just incredible. So we started off around software solutions, IP, they're getting involved in the hardware. They're actually got a really good team now that's helping us innovate around AI as well, around models and how do we demonstrate and enhance our AI capabilities. They're helping us with proof of concepts. They're helping our customers come up with, hey, here's what I can do with an FPGA, and demonstrating that. So they take our FPGA and they're really showing and highlighting the capabilities of that FPGA. And then by doing that, they're also able to learn more and give us more feedback on how we build the next generation FPGA and how can we make that even better from an AI perspective.
Are they also collaborating with global teams on this?
They are. They're collaborating with our teams in North America as well as our teams in APAC as well.
If you were to define Lattice's vision for the next 5 years in a single sentence.
Look, we're the low-power programmable leader, and we build small and mid-range FPGAs that are differentiated in the market. And we'll continue that. And the differentiation is around power, it's around form factor, it's around boot time, and we believe that the ecosystem and partnering is very important because they help us innovate. They innovate with us, and they help our customers innovate.
Well, I wish you all the best.
Thank you.